Hello all, I'm Ahaan and we'll be speaking on file management in iOS. We'll be going through Sandbox, Common App Directories, Apple File System, Coordinators and Presenters, and Security. I'll start with Sandbox. Apple always gives a lot of importance to security. Sandbox is a feature that encloses each app within its own box, so to speak. Mostly, an app is not allowed to interact with any data outside of this box. Similarly, outside apps are not allowed to access anything that is within this box generally. So basically, each app has its own sandbox directory where it can store its data while also maintaining a private environment for the app to ensure security. We'll now look at the container directories present inside the sandbox. Most of these are created during installation. Bundle container directory contains the app's bundle. We'll look at it in the next slide. Data container directory contains data of app and user. At the same time, the app can also request access to additional container directories such as iCloud container during runtime. If we now look at the case of WhatsApp, it clearly accesses the contacts of the user. These contacts are certainly stored outside of WhatsApp's sandbox directory. So how does it do that? To access information outside the app sandbox, an app can use public system interfaces, and with the help of certain helper applications, it can access the required data. We'll now look at the common subdirectories present within the sandbox directory. AppName.app is the app's bundle. It contains basically the app itself and all of its resources. It is written only during installation and is hence read-only. Documents contains user-generated content which is accessible to the user. Document/inbox are used to access files that the app was asked to open by outside entities. If we take the examples of email attachments, then these email attachments were sent by outside and they were not generated within the app. Library directory contains all files that are not user data files. They're not even accessible to the user. The TMP directory stores temporary files that do not need to persist between various instances or launches of the application. This directory may hence be purged while the app is not running. That's it from me. Thank you.
Hi, I am Divyam and I'll be talking about the file system of iOS. A file system manages how data is stored and retrieved on a storage medium like a hard disk. So Apple File System is a new generation file system which replaces HFS Plus as the default file system for iOS 10.3 and later. It offers various benefits mentioned in the slide. So let's see some of the key features of APFS. Space sharing. Many file systems like HFS Plus support only a single volume per partition. So in the case of HFS Plus, the data can grow only inside its volume. However, in the case of APFS, there could be multiple volumes inside a single container. So all those volumes share their free space. APFS volumes can grow and shrink inside a container. So let's say if I want to add more data to volume 1, then we can increase its size in this free space. Cloning. APFS clone is a copy of a file or a directory that occupies no additional space on the disk. In the case of HFS Plus, copying allots new blocks to store the copy of the data. However, in case of APFS, cloning copies the references to the data and not the actual data. So it is fast and power efficient. It is based on the concept of copy on write. That is, the modifications of data are written only in case there has been some changes made. So in this example, if we have made the change to the second block, only in that case it is written elsewhere. Another feature is snapshots. Snapshots are read-only instances of the file system at a given point in time. So as we can see in this figure, the green blocks represent the time at which the snapshot has been taken. Now, any change made after the snapshot are written to a different location, as we can see by this blue block. So this preserves the snapshots. The advantage of snapshots is that it makes possible to roll back the file system to an earlier state. It ensures data reliability. Snapshots are fast and inexpensive to create. Sparse files. In the case of sparse files, on-disk blocks are allocated only when those blocks are actually written to. So the advantage is that the files which contains blank sections can be saved more efficiently. So let's say we write a block of data, then seek one block and write another block of data. Then in the case of HFS plus, we leave an empty block. However, APFS is efficient as it doesn't allot the second block. However, writing to the second block later may result in out of order blocks. So this leads to fragmentation, though the performance loss due to it isn't much. That's it from my side.
Hi, I am Aniket and I'll be taking coordinators and presenters. So we know that file system is shared by all running processes or multiple threads of a single running process. So two processes or two threads in a single process may make changes to a file unexpected to other processes, and this may lead to crashes or data corruption. To synchronize their activities, we have file coordinators which allow processes to coordinate the changes or access to a file. It notifies the process or a thread accessing a particular file whether the file is being used by some other processes or thread or not. The access to a file is made by an object of an app by designating that object as the file presenter. Any object can be made as the file presenter and it will be notified of any action by an object to the file. A file presenter may not only monitor activity or access or changes to a file, but also to a particular directory as well. Now, with development perspective, iOS has UI document class which encapsulates data for user document. It automatically supports NS file coordinator, NS file presenter, and autosave implementations. This class is protocol required or necessary for file coordination and file presentation. Now, security in iOS file system. iOS provides three security schemes: Unix PST permissions, POSIX access control lists, and sandbox entitlements. These permission models fit as follows. If the app sandbox forbids the requested access, the request is denied. If the ownership checking has been disabled for a particular volume by the system administrator, the request is granted. If an access control entry exists on the file, it is evaluated to determine access rights. If a file flag prohibits the operation is denied. Otherwise, if the user ID matches with the owner of the file, the user or owner permissions are used. Otherwise, if the group ID of the app matches with the group of the file, the group permissions are used. Else, the default or other permissions are used. Now, permission models in macOS are similar to iOS, but in iOS apps, they are limited by the sandbox and can generally access the files that are created by that app only. Apps can access other files such as address books and photos through APIs which are specially designed and designated for that purpose. If file protection is enabled on an iOS device, apps can choose to prevent access to specific files when the device is locked. iOS also has provision that encrypted files in iOS are also encrypted in any backup of the device that is performed. So that's it for the presentation, and thank you for your patience.